Let's solve this GATE 2001 question. Prove that power set of A intersection B is equal to power set of A intersection power set of B. Let's solve this. Let me tell you that this question you cannot solve using Venn diagram. So that is the limitation of Venn diagram. Venn diagram does not work when power set is involved. So you can notice in case of power set related statement, okay, the Venn diagram method cannot be used. This is the limitation of Venn diagram method. In the GATE exam, whenever there is a question related to set, then you should definitely apply the Venn diagram method because this is very easy. But remember, in the case of power set related statements, this Venn diagram method will not help you. Okay, so that is the reason complete formal analysis is very important. In the class we have done this for many questions. Okay, for all the questions we have done this Venn diagram also, because this is useful for the GATE exam. But this complete formal analysis also we have done. So these two things we have done for every question. Okay, because these are important. I told you that Venn diagram is not useful for this power set related questions, but this complete formal analysis, this you can use everywhere. This you can use everywhere. This is applicable everywhere. Okay, every time you can use it. This you can use every time. So that is the beauty. Okay, now let's solve this question with this complete formal analysis. But let's see the concepts that you need to know. So remember, okay, these are the concepts we need to know. So if you know, see, first of all, if X belongs to power set of A, then what can I say? Then I can say if and only if X is a subset of A, correct? Because in the power set of A we have subset of A. So I can say if any element X belongs to power set of A, then it automatically means that I can say if any element belongs to power set of A, then I can say that X is a subset of A. And I can also say if X is a subset of A, then I can say that X belongs to power set of A. This is the definition of power set of A. Okay, so these three things we will use. What else we will use? Okay, so you can notice that if let's assume that A is a subset of B union C or B intersection C, then what can we say? If A is a subset of B intersection C, then definitely A is subset of B and A is subset of C. Then definitely A is subset of B and A is subset of C. Why this will happen? See, from the Venn diagram you can notice in this Venn diagram, this is set A, this is set B. So you have two set A comma B. Now I am saying that if let's assume, okay, so let me write like this. Okay, so this is, let's assume this is set C. Now I am saying that if set A is a subset of B intersection C, okay, then what it means, remember this is B intersection C, this is the area B intersection C. So if A is a subset of this area, if A is a subset of, so I can say that if A is a subset of this area, then definitely A is subset of B, because A is subset of this area means this is A. Let's assume this area is A, this is A. So you can clearly see that A, definitely A is subset of B, and also A is a subset of C. So this is the result. So basically this result also we will use. Okay, so if A is subset of B intersection C, then I can say okay, this reverse direction, if A is subset of B and A is subset of C, okay, means A is subset of B also, A is subset of C also. Okay, so means every element of A is in B also, every element of A is in C also. Then I can say, what can I say? Then I can say that A is a subset of B intersection C. Because remember, every element of A is in B, every element of A is in C. So every element of A is in both of them. Every element of A is common between B comma C. So I can say that if A is subset of B and A is subset of C, then I can say A is subset of B intersection C. So basically these are the things, these are the concepts we are using. So I can say that A is a subset of B intersection C if and only if A is a subset of B and A is a subset of C. So this concept we will use. Okay, remember this proof. Let me just tell you this proof. Okay, so basically if you know that A is subset of B and you know that A is a subset of C, then can I say then can I say that A is a subset of B intersection C? Let's see. See, okay, what this means? This means that if any element X belongs to A, then it also belongs to B. Okay, and what this means? What this statement means, this statement means that if any element of a, if any element, this element x, if this element x belongs to a, then this element also belongs to c. So you can notice that for all x belonging to a, what can I say? I can say for all x belonging to a, what can I say? Definitely x also belongs to b and x belongs to c. Okay, and from this I can say that x belongs to b, x belongs to c, and this basically means that x belongs to b intersection c. Okay, because x is common in b comma c, so I can say for all x belonging to a, for all x belonging to a, I can say x also belongs to b intersection c. So I can say that a is a subset of b intersection c, because every element of a, every element of a is in b intersection c. So I can say a is subset of b intersection c. Okay, so these are the statements we are going to use. This statement we will use, and as I told you that this statement we will use that, okay, x belonging to power set of a, okay, x belonging to power set of s if and only if x is a subset of s. So these two statements we are going to use. Now let's solve this question. Okay, let's start this question. So the question is saying that prove that power set of a intersection b, so a comma b are two set, and this is what we need to prove, that power set of a intersection b is equal to power set of a intersection power set of b. So here we have equality, and remember, whenever you want to prove that two set are equal, then what you need to do? Okay, so to prove, if you want, if you want to prove set equality, then what you need to do? If you want to prove set equality means, if you want to prove that x is equal to set x is equal to y, okay, then what you have to do? Okay, to prove that this set is equal to this set, this is what you need to do. Okay, you need to prove that x is subset of y, and you need to prove that y is subset of x. So these two things you have to prove if you want to prove that x is equal to y. So if you want to prove that this set is equal to this set, then what you need to prove? You need to prove two things. Okay, so basically the part one, what is the part one? The part one is that you need to prove that this power set of a intersection b, this is a subset of power set of a intersection power set of b. So let me call it LHS. Basically you need to prove that LHS is subset of RHS. So let's see how to prove this. Now whenever you want to prove that something is okay, now okay, so to prove, if you want to prove that, if you want to prove that x is a subset of y, what you need to do? The method is very simple. Just assume that some element belongs to x. Okay, and then what you do, then you prove that a also belongs to y. So just assume that some element is in x, then what you do, you prove that a is also in y. Then it means every element of x is in y, every element that is in this set, that is also in this set. It means what you have done. Okay, so if you do this, okay, if you do this, then I can say that x is a subset of y. This is the idea. So if you want to prove that this is a subset of this, what you can say? You can say that assume that some element belongs to this set. Okay, this set, let's assume that, so let me assume that some element x, okay, that belongs to power set of a intersection b. What this means? X belongs to power set of a intersection b. This means x is a subset of a intersection b. This is what I am saying. I am saying that if x belongs to power set of s, then it means x is subset of s. So I can say if x belongs to power set of a intersection b, then I can say x is subset of a intersection b. And we have seen x is subset of a intersection b. It automatically means that x is subset of a and x is subset of b. So this we can use. We can use if a is subset of b intersection c, then a is subset of b and a is subset of c. So I can say if x is subset of a intersection b, then I can say x is subset of a and x is subset of b. Now x is subset of a, x is a subset of a, and x is a subset of b. What this means? X is subset of a. This means x belongs to power set of a. And what this means? This means x belongs to power set of b. Okay, so you can notice that x belongs to power set of a and x belongs to power set of b. So x is common between these two. Between this set and this set, x is common. So I can say x belongs to their intersection. X belongs to their intersection. And this is what we wanted to prove. So see, I am I am assuming that X belongs to this set, and then after that I can prove that X belongs to this set. So you can clearly see X belongs to PA intersection PB. So I can say that what I have done, this is what I have done, that power set of A intersection B, this is subset of power set of A intersection power set of B. So this proof we have done. Okay, so very step by step I have gone. Assume some element is here, assume this element X is in this set, then what it means, so this is your assumption, so this is basically the assumption. So here this is what you assume. Okay, so just assume that X belongs to P. Okay, now from this I can say this, from this I can say X belongs to P A intersection B, it means X is subset of A intersection B. And from this I can say X is subset of A and X is subset of B. X is subset of A, it means X belongs to PA. X is subset of B, it means X belongs to PB. X belongs to here also, it means X is common. I can say X belongs to their intersection because X is common in this set and in this set. So I can say X is common. So I can say X belongs to their intersection. So finally, this is the proof. Now let's see the part 2. What is the part 2? In the part 2, we need to prove that PA intersection PB, this is a subset of PA intersection B. This is what we need to prove. The idea is same. What you will do, just assume that some element is here. Okay, so this is our assumption. So we will start with this assumption. Assume that some element X belongs to this LHS, means PA intersection PB. Now from this, what it means? X belongs to their intersection. X belongs to this intersection, this. What it means? It means X is common in this comma this. Okay, because X is common between P comma PA. So from this I can say X belongs to PA, and I can say that X belongs to PB. This is what we can say. Now X belongs to PA. It simply means that X is subset of A, and X belongs to PB. It simply means that X is subset of B. X is subset of A and X is subset of B. This is what we have seen. X is subset of A and X is subset of B. Then basically X is subset of A intersection B. X is subset of A intersection B. What this means? X is a subset of A intersection B. This means X belongs to P power set of A intersection B. Right? So X belongs to power set of A intersection B. So this is what we wanted to prove. You can notice we are assuming that X belongs to LHS. Okay, now I can say that X belongs to RHS also. So for every element, if any element belongs to this set, then it also belongs to this set. So what we have done, so we have proven, so this is what we have done. So we have proven that power set of A intersection power set of B, this is subset of power set of A intersection B. This is your part 2. We have also seen that power set of A intersection B, okay, this is subset of power set of A intersection power set of B. And from these two I can say, okay, I can say basically it's like this. It's like this, X is subset of Y is subset of X. So from these two I can say that X is equal to Y. So this is the idea. So I can say that power set of A intersection B, that is equal to power set of A intersection power set of B. So this is the proof. Very simple. Remember the okay, in this question power set is involved. So if there is any question related to power set, then Venn diagram cannot help you. This complete formal analysis is very important. Okay, and you can notice in this question this is what we have done. So first I told you all the concepts that we need to know. These are the basic concepts that we have seen in the class. Each of these concepts we have seen already. We have seen each of these concepts, but I am again telling you that these concepts we will use in this question. Okay, so in this question, using these concepts, what we have done, we have proven, okay, this statement we have proven, and this is the our task. So we have proven this. Now let me tell you one variation. So you can clearly see that power set of, you can see power set of A intersection B is equal to power set of A intersection power set of B. But you should also think, is it true? Think about this. P of A union B, can I say P of A union P of B? Is this statement correct? Think about this statement. Is this statement correct? Pause the video and think about it. Is this statement true or false? This variation. So let me tell you, this statement is actually false. This is actually false. This statement is actually false. Why? Very easily you can see. Let me give you one counter example. So let's assume you have set A. Let's assume this is your set A, and let's assume this is your set B. Okay, so I can say that I can say this is your set A and this is your set B. Now what you can see, if this is set A, this is set B, then what you will get? What is the power? Okay, what is the power set of A? Or I can say what is the number of elements in power set of A? See, clearly see. So the what is power set of A? Here the power set of A will be 5 comma this will be the power set of A. And what will be the power set of B? Power set of B, that will be basically 5 comma 2 comma 3 comma 2 comma 3. And what will be their union? What will be power set of A union power set of B? So that will have 6 elements. You can, okay, so actually that will have, okay, these are the 4 elements, these are the 2 elements. So finally this 5 is common. So actually this will have 5 elements only. So this power set of A union power set of B, this will have only 5 elements. And how many elements will be there in power set of A union B? So you can notice A union B, that is 1 2 3. So how many elements will be there in the power set of A union B? In power set of A union B, how many elements will be there? There will be 2 power 3, means total 8 elements will be there. So you can notice here you have total 8 elements, here you have only 5 elements, then definitely they are not equal. So this statement P of A union B is equal to P of A union P of B, this statement is false. Clearly this statement is false. Okay, because this for this example you can notice this will have 8 elements and this will only have 5 elements, then definitely they are not same. Now let me tell you, okay, this is not equal, but one of them is subset of another. One of them is a subset of another. Okay, which is that? Which is that? So just think about it. Again, you pause the video and think about it. One of them is subset of another. So actually this is a subset of this. Okay, so this we can prove. Okay, so let's prove that. Okay, so this is what we need to prove. Prove that P of A union P of B, this is subset of power set of A union B. This we can prove. How will you prove this? See, again this method is same. If you want to prove that this X is subset of Y, then what you need to do? Just assume that something belongs to it, some element belongs to it. So okay, so let's assume. So okay, you will start with the assumption. So let's assume that some element X belongs to power set of A union power set of B. What this means, remember there is a symmetry here because this is union, so there is a symmetry. So X belongs to power set of A union power set of B. What this means, this simply means that X belongs to at least one of them. X belongs to this union this, it means X belongs to at least one of them. At least one of them, either this or both of them, at least one of them. So okay, because there is a symmetry, you can assume whether X belongs here or X belongs here, because there is a complete symmetry here. You can assume P of A. Okay, so let me assume P of A. So let me assume that X belongs to P of A, because there is a complete symmetry. You don't have to worry. You can assume X belongs to P of A, or you can assume X belongs to P of B, or you can, okay, so this is the idea. At least one of them, definitely it will happen. X will definitely belong to at least one of them. Okay, so let me assume that because of symmetry, I am assuming that X belongs to P of A. What this means? Again, what this means? This simply means that X is a subset of A. X is a subset of A, then automatically X is a subset of A union B. If X is subset of A, then automatically you can see. Okay, so see this. If I can say if A is a subset of B. Okay, so this is the idea. If S is a subset of T, if S is subset of T, then definitely S is subset of T union anything. S is subset of T union anything. So this is the idea. If S is already subset of T, okay, then I can say that S is definitely subset of T union R. Okay, so this is the idea. So if X is already subset of A, then I can say X is subset of, okay, then okay, so from here I can say, then I can say X is subset of A union B. What this means, X is subset of A union B, it means X belongs to power set of A union B. Because X is subset of this, so X will belong to power set of A union B. And this is what we wanted to prove. This is what we are assuming. We are assuming that some element is here. Now we are proving that if some element is here, then automatically this element will be here. Okay, so this is the idea. So I can say X belongs to power set of A union B. So what we have proven, so this is what we have proven, that P of A union P of B, this is subset of P of A union B. This is what we have proven. Okay, so this is what we have proven. The other direction is not correct. Remember, we have already seen counter example for this. This is a subset of PA union PB. This statement is not correct. Okay, and the counter example I already told you. So if you want to see the counter example, then you can just prefer this example. For example, you can take set A as this, and you can take set B as this. Now this will work as counter example for this question. Okay, so these are the variations. You can clearly see all the variations we have seen. So this is your original question. This is the original question, the proof we have seen, and then we have done this variation also, the in terms of union, this variation we have done. Okay, so like this. So this is the complete analysis. For every question you should do complete analysis. I have seen many students, what they do, they get the answer. Okay, once they get the answer, then they move on. See, for every question you should do complete analysis. You should ask, okay, in this question you should ask, what will happen if intersection. Okay, see, here we have intersection, but you should ask, what will happen if there is union. Okay, so this type of questions you should ask. So this is the complete analysis of this gate 2001 question. This is what we have proven, and we have seen one variation also. Okay.